So it's the group quiz under week 5.
Yeah. Okay. Okay, that's what I was asking. All right, we go back to there. Sweet. Ready when you are.
All right, cool. So number 1, that was easy. That is true.
Oh, wait. Yeah, let me open it.
Okay.
All right. Yep, that one is true.
Number 2 is the second one. A random
variable
brand of toothpaste.
Oh, is this when you? Oh, okay. Which of the following variables are categorical?
It's categorical is the ones that aren't numerical.
Right. You can't put a number to it.
Yeah. Yep. Number 3, the mean IQ test score in the U.S. is 100. 20 random selected statistics students took the IQ test, and the mean of their scores was 112. Which the following statements are true? So this one, I wasn't 100% sure, but I thought the 100 is the parameter, and then the 112 is the statistic.
I think you're right.
Because if the U.S. is providing a mean already,
right,
the score mean, and then we're doing a study on it, we're trying to find out our own kind of things. That's why I put 112 as statistic.
Right. Okay. I'm good with that.
Okay. Number 4.
The property values are similar to each year. Huh.
I think this one.
It would be either cluster or stratified, correct?
Yeah. I wasn't sure which one, but I got the definition in front of me. So, stratified is subjects are in groups according to similarity of some characteristics, such as age, income, political party, and then specifically take a simple random sample from each group.
Okay.
And that's for stratified.
All right, and the clustered?
The cluster subjects are put into groups that hopefully represent the population. Randomly select one or more groups and sample everybody in that group.
You could almost pick either one.
Yeah. I think more so, let's see.
Well, is the cluster is grouping them both and averaging it, correct?
The cluster is hopefully representing the population, and then everybody in one or more groups that you get is tested. So the stratified is more of an average.
Okay.
Should we try stratified on that one?
I have it as stratified. Yeah, because then they're all going to be, they will all be the same property values, so property taxes. So,
okay.
Yeah, I think stratified.
Okay, sweet, let's do it.
Design experiments are conducted in public. Ooh, we got a bunch of questions this one.
Yeah. So this one, I think this one is also stratified random sample. So I guess this one is a stratified random. The last one is stratified sample. So I guess they're a little different.
What design are conducted in public school system? Churches typically choose a particular district. So it's taking one out of the particular group and then averaging them over all of this.
Okay.
That's a simple random sample though?
Well, yeah, but they're going specific to the district and then randomly selecting teachers. So wait, let's see. Wait, this would be a cluster. Okay, because clusters random or hopefully represent the population, which would be the district.
Yeah.
And randomly select one or more groups and sample everybody in that group. So there's
Oh, is it every? Yeah, okay. I didn't see that it was everybody in the group. Select. It says randomly select teachers of say 4th grade students in that district.
Okay.
So they're selecting a random teacher and then testing all the kids. Yeah, you're right. Maybe a cluster.
Okay. All right, number 6. So this one.
Oh, that's simple random sample. Yeah. Because that's every 6th name. Or
this one's just randomly. 6 names are drawn, but it's just randomly 6 names drawn. So
yeah.
the one you're thinking of.
It's where they pick the one.
Yeah.
And then they keep using that one throughout the whole thing. So.
Yeah. Okay, so for this one. I think this one's stratified as well.
Yeah, because that's just picking somebody. So that would be, I think, a stratified.
Okay.
I think you're right. Yeah, because you're just getting grouped with everybody and then picking a name out.
Yeah.
Or 6 names out.
Okay.
Special interest group conducting.
Anything else? I'm pulling mine up right now on the Excel.
What's that?
I'm pulling the Excel up right now.
Oh. Oh, you're on. Oh, okay. You're on level 8 or number 8.
Yeah.
Okay.
So the mean, is that what number 8's asking for, is the mean? Okay, the mean, yeah. So the mean, I just did it on the software, is 4.771.
Sweet.
It says round up to this.
Hey, what was number 6? Did you?
Number 6, I put a simple random sample.
Okay.
Number 9, let me do that real quick. Standard deviation.
Oh, yeah, I gotta pull that up.
1.912.
Where'd you go? There you are. I was pulling my Excel up, sorry.
No, you're good.
For some reason, it's taking some time. There it is. Where'd that come from? All right, I'm lost now. Hold on one second. I lost my test for some reason.
Okay.
Somehow I closed out everything.
Oh no. I think usually it just resumes once you're logged back.
Yeah. Yeah. Well, we're allowed 2 on this too, so. Okay, now I know where I'm at. Oh shoot! It just told I didn't save it, so sorry.
That's okay. I'll read
Hold
them
on,
off.
let me. Yeah, I got 1, 2, 3. It's saved. 3, 4 is good. 5 is stratified, isn't it?
We put a cluster sample.
Oh, cluster. Okay. Let me save them this time so I don't have this. 6 is stratified.
A simple random sample.
Sent them.
A simple.
How did I get stratified on that? I know I clicked it.
This
All
one's
right.
out of school fundraiser.
Yeah.
Yeah, so a simple random sample.
All right. And then 7 is
Stratified.
stratified. Yeah. And then Crossroads was 4771.
Yep. 4.771.
Yep. Okay. And then 9.
I got 1.912.
That's what I get for having so much stuff open. All right. And then
Number 10 is creating a histogram. And on my portion, because I printed mine off, I did it before. I completed mine, and there's 6 different things on the histogram, 6 different bars on the histogram.
okay.
So basically, you just highlight all the prices, and then you go up to insert a chart, and you do the histogram one.
Right.
That was not hard.
Yeah.
For number 11, this lady, Jessica Muir, they basically do a test on seals that dive, and they give the temperatures and everything right there in that first table, 37.91, 37.25.
Uh-huh.
So what I did is I took the mean of those 4 numbers, and the mean was 38.075. And in the second table, to get the number A, which is number 11, it wants us to figure out what A is.
So you got to do your mean minus the bar mean. So
you do you do 37.91 minus the mean, which was 38.075. And for the answer, I got negative 0.165.
Oh, okay. I know what you're talking. Yeah, I see it. All right. And then your squared deviation would be that negative 1.65. Oh, well, it'll change because it's a different number on the bottom.
Yeah.
So 38. There it is. Yeah, there we go. Clear. 37. That thing sucks. Sorry, my calculator died.
All right. Are you doing number 11 or 12?
Sorry about that. My phone rang and I couldn't hear.
That's all right. Are you on number 11 or 12?
Number 11 or number 12. Number
Okay.
11 to negative 0.165, correct?
Yeah. So for number 12, we do the same thing. We take the x, which is 37.25 minus the mean, 38.075, and square it.
Yeah.
And we got 0.681.
0.681.
Yep. Number 13. This one took me a while to think about, but it says what quantity is equal to the sum of the numbers in the squared deviation column. So if you go back up to that table, that's the last column. And then the sum goes into the equation for variance. So it's not the mean, it's not the standard deviation, it's not the variance. So that's why I put none of these is correct.
None of these are correct. Okay. What is the standard deviation of these temperatures?
So on this one, I was guessing it's after the dive. So it'd come from that last column. If you solve all those and perform the standard deviation for all of numbers.
Hold on, my headphones. Somebody's calling me on my other phone, so it keeps kicking me off. I'm gonna shut this one down.
Okay.
All right. Sorry about that. My phone keeps ringing and texting, and my headphones, because it picks up both my computer and my phone.
That's okay.
So every time it beeps on the other line, it shuts off my headphones, and I can't hear what anybody's saying.
That's all right.
So the standard deviation of the temperatures on the dive part?
Yeah, so for number 14, it says, what is the standard deviation of these temperatures? So when it says these temperatures, if you go back up to that table, do you think that means the first column or the last column?
Does it say after?
No, it just says for these temperatures. So I got both standard deviations.
I would guess what quantity is equal to the sum of the numbers in the squared deviation column? What is the standard deviation of these temperatures? So I think it might be a add-on to the question beforehand. So you have the value of the number that goes in the position mark B,
Mhm.
and then what is the equal to the sum of the number in the squared deviation? So
So it'd be after the,
yeah, I think so.
all right, so that one is 0.619. And then if that doesn't work, then we'll put the
Yeah.
other standard deviation next time. Under certain conditions, the standard deviation can be negative. I put false because you're squaring it. Or wait,
The standard deviation can be negative though, can't it? Because you're going to have it on both sides. So your standard deviation be, well, because then you get your z-score off of that. So
okay. Yeah, so it can be then. Okay, that makes sense.
right, because if you're, let's say you're one standard deviation off, that means you're going to have a negative one standard deviation also.
Okay, that's true. Good catch. Okay, so number 16.
Extradural.
Yeah, because the standard deviation isn't high, right?
Yeah.
Okay.
Because I think the farther away from the mean, the more, the higher the temperatures would be.
Yeah. Sweet. Okay, 17. The third quartile is 8. Right?
The number of hours students spent studying for an exam were recorded. The data are represented by the box plot. Use the box. What is the third quartile? Your first is from there to there. That's your median. So you have 1, 6 to 12.
So 6.
Or, yeah, 6 to 12. Yeah, that should be your third quartile.
6 is the median, and then I think 8 is the third quartile, though.
No, because you still have your dot though.
Yeah, I saw that too, and I was like, I didn't understand that part.
So I think it goes all the way, even though you do have the extreme outlier. That's what it's called.
Okay. So
I don't know if I don't know if we add that though. That was my question before.
I don't think we add that one, but I remember reading something about the extreme, so I'm not sure.
So on the question, or so on the answer, do we put 6-8?
What's the third?
Oh, that's the third quartile, so that would be.
I think it'd just be 8.
Yeah, I think you're right.
Let's see. Oh, I'm off my toes on this one, because this one's. I don't know. I don't like these ones because I'm not really explanatory.
Yeah. Well, I know on the box plot, your box plot is just your histogram set up in a different, in a different box or in a different way. So if you had the histogram, you'd see that 2 to 12 is where your lines are, right?
Uh-huh.
That's where most of your study comes in at, and then your median is 6. So you have to work off of that. So assuming that 2 is your 0, then 4 would be your 25, 6 would be your 50, 8 would be your 75, and then 12 would be your full 100%. So yeah, I think so.
Okay.
That's what I would go for.
Sweet, that makes sense. Thanks for explaining that.
What percentage of data lies between 4 and 8 hours?
So between 4 and 8, that should be 50% because it's 75 minus 25. So it'd be 50,
Yep.
right? Okay. So you just put 50.
Are I'm not sure about that one. I don't know if it's 50%. Because if you use the applet between 4 and 6, I mean that's your majority of your percentage. Oh, maybe you're right. Because that's going to be one standard deviation off, correct? So, or well, you don't know. I mean, I think I'm overthinking that one.
Yeah, so there's 5 points right on that box plot.
Yeah.
And so the first quartile is the 25th percent, and the third quartile is 75th percent. And so that's what I did. Is I just took 75 minus 25.
And then just did the 50. Okay. All right. I'm good with that.
Okay. So for the mean, number 19, what I did is I took the 1.59 plus 2.52 and then divided it by 2 to get the mean. I'm pretty sure that's how you do it.
1.5. 1.56?
For the mean,
Yeah.
I got 2.055. So I did 1.59 plus 2.52, and that's 4.11.
Oh, you know what? I did 3.11. Yeah, my bad. So I should use a calculator, right? Yeah, 2.5. Well, it'd be 2.56. 2.55.
Yeah, 2.055.
Okay. All right. Yeah, I was right.
And for the standard deviation, I got 0.233.
233. Yeah. So now you put that number 233 in the applet, correct?
Yeah. Let's see. So the mean, I don't know. I didn't really use the applet on this one, but I'm sure it worked. What I did on this one is I took the mean, 2.055, and I added 0.233, and I subtracted 0.233. And the answer I got was 1.823 and 2.288, the last one.
Two, three, three. And then it's oh, I'm sorry. Yeah. And you said the 1.59 and the 252?
No, the one under that 1.823.
1.8. Okay.
Yeah. So I just took the mean, and then I did up one standard deviation and down one standard deviation.
Right. Okay.
So that's the 68%.
Yeah. Yeah, that's right. 68, 95, 99, right? Or
yeah. Okay, so on 22 we do use the applet, but we have to solve for the z-score. So on this one, I take 542, which is the score. They're asking how many will score above 542.3.
yeah.
Minus it by the mean, which is also 542.3. And you divide it by the standard deviation 120.54, and you get 0. So when you type in 0 for the z-score, it's going to be right in the middle, so it's going to be 0.5.
0.5, yeah.
And then 23, anything below 600.
It's everything below the 0.5.
No, so this one's different because we got to do, it's a different score now. So we do 600 minus the mean. I think that was 542.3. Divided by the standard deviation. So our new z-score is going to be 0.479.
So we go 6. Five, 4, 4, 9, 4. All right, so I did something wrong on that one.
Okay, so what I did was, so I took 600, which is the score.
Right.
Minus 542.3.
That's what I did.
Which is the mean, and then you divide that by the standard deviation 120.54. And that's the new z-score, which is 0.479. And
So I got, yeah, so that's what it was. I didn't equal it out when I subtracted, so that's.
Oh, okay.
That's why I was like, wait a second, what did I do?
So the answer that I got for everything below 600 was 0.684.
Okay, so you had 0.4786 on the number, right? For your z-score?
Yeah.
Excuse me. That's 6840, correct?
Yeah.
Sweet.
Nice. And then 0.4, it's the same thing, it's just everything above 600.
.316.
Yeah, that's what I got too.
10th percentile. That's 0.10, correct?
Yeah, 0.10. That you type that in the area.
Yeah. And so they said above. Wait, what was it in the question? Oh, it corresponds to the 10th percentile. So.
Okay, so for this one, when we type in the area at the top, 0.10, it's everything below the negative z-score. So then
okay.
we take that z-score and we basically make a formula out of it to find x. They want to know what score it is, so we're solving for x.
Okay, so -1282
equals x minus 542.3 divided by 120.54.
Oh, okay, I remember now. Kinda.
So it's the same equation that we've been doing the last two questions. It's just we're kind of working backwards. So with the 10th percentile, right, you found your z-score of -1.282.
Right.
So now you just do that and then plug the equation in. So -1.282 equals x minus 542.3, which is the mean.
Yeah.
Divided by 120.54, which is the standard deviation. And to solve for that, you do -1.282 times 120.54.
And then divided by the 542.
And then you add.
Yeah.
Add 542.3. And so that answer should be 388 for the score.
Three hundred 388, is that what you said?
Yeah.
Yeah. Okay, that's what I got.
Sweet.
387.7.
Yep. But we're rounding to the nearest whole number, so it's 388.
Yeah.
Okay.
So then we just do it with everything above that. So that would be the same number.
Just a positive this time. So 1.282 equals x minus 542.3 divided by 120.54.
So it's just going to be the negative. So, oh, that means you just add numbers. So 1.282 times 120.54 plus 542.3. 696.8, so 697.
Yeah, that's what I got.
Sweet.
Cool. Good job.
Find the first quartile.
So the first quartile is 25%, so type in 0.25 for the area. And it'd be everything under the negative 0.674 z-score.
Like 0.25. Okay, so yeah, 0.674.
Yeah.
That's our z-score, right?
Yep. And then we make a formula out of that, same formula.
Do the same thing, right?
Yeah.
All right, so
for negative 0.674 equals x minus 542.3 divided by 120.54.
$461.
Yeah, that's what I got. And third quartile, so 0.75.
So 674. So it's going to be the same number except just positive, correct?
Yeah.
674 times 120.54 divided by plus. So that's 624.
Yeah, that's what I got too.
Sweet.
Perfect.
Students taking. So now you got to plug in the n, right?
Yeah. What is the mean of the distribution? So the mean, it would be the same thing, wouldn't it? It'd be 542.3.
Yeah. Well, now you're taking a random sample of 15 students, though. No, but it's the mean. It shouldn't change because you're still having.
Yeah.
But I guess it's going to change because now you're only doing 15 students. But shouldn't it still be the same?
I think it should still be the same.
The standard deviation might change, correct? But the mean's still going to be the same?
Yeah.
Or vice versa, one or the other.
I think, pretty sure the mean stays the same, but the standard deviation will change because you can do, the standard deviation would then change to be 120.54 divided by 15 squared, or 15, the
square root of 15. Yeah, you're right. Okay, so 542.3. And then, so now we're going to do the mean of that, or the standard deviation of that one. Because now it's a sample. And then this divided by the square root of 15, right?
Yeah, so 120.54 divided by square root of 15. I got 31.123.
Here, let me see what good old Apple says. All right. 120. Square root. Uh-oh. Oh, 15. All right, what did you end up getting?
31.123.
Ooh, I'm off on that one. Okay.
So for this one, all you got to do, I think this was in lesson 6.
Yeah.
This one, you just do 120.54, and then you do it divided by the square root of 15. So let me see. So I just did, let's see.
31,123. Oh, okay. I see what I got to do. Yeah, it's just me and calculator skills are horrible. So.
All right, and then number 31.
Then you do the same thing, right? Now that you have the mean, the standard deviation off the 31,123, and it's still your square root of 15 will be greater than 600, correct?
Yeah, so we're trying to find the probability greater than 600, so we do 600 minus 542.3 divided by that standard deviation above, 31.123. And that's how we get our z-score, and then we plug that into the applet.
Right. Okay, let me see. So okay, so then you 31. I actually messed up the formula. So okay, so after you have your sample, your 600, and then you subtract it by the mean.
Yeah.
All right, and then you
Divided by
the
31.123. Yep.
133. Okay, yeah, that's what I.
Yeah. And so for that z-score, I got 1.854.
Okay, on the formula, what was the number? What did you end up with? What number? Negative
1.854.
1.854. Yeah, I had that on the last one. Okay.
And then you just plug that into the applet, and it's everything above that.
And 0.0319.
Yeah.
Sweet.
So then rounding would be 0.032.
All right, you ready?
Yep.
Ooh, missed one. 11 and 14. And I missed 15 too, so. Oh, you were right on the standard deviation could be negative.
Oh, I
It's
was?
false. Yeah, it's false.
What was that, 15?
Yeah.
Okay. Sweet, not too shabby. Out of 31 questions, that's good for us.
No, that's awesome. Good job, man. I say let's do this again because you get 2 chances on it.
Yeah.
Hopefully they're the same answers.
Yeah.
I don't know why I'm doing this, but I like doing it, I guess. So,
Well, if we took the test right now, we know we get an A. If it was the same question.
yeah. Are they the same questions?
I don't know if they are or not. That'd be awesome though.
Oh, well, that would make my day.
Yeah. Mine too.
So 15 is false. And 16 is not 0.619. What number did you get? What did you get on 14?
I did the same one, but that was the one where it was either before or after the dive.
Oh, yeah. Okay.
So let's try the standard deviation of before the dive, which is 0.715.
All right. And then 13's none. And then for some reason, I got 11 wrong.
Number 11. Let me see what I took. Number 11, I did negative 0.165.
Oh, you know what? That's why. Okay. I put negative 0.165. That's why I got to be different.
Wait, what number was that again?
11.
Yeah, so negative 0.165 is what I put, and I got that one right.
Negative 0.165. Yeah, I put negative 165.
Okay.
Number, I mixed up the number.
Um,
Like normal. All right, true. Okay, so I'm betting that this is still open. All the way to the top here. Stratified, cluster, simple random. Okay. I'm almost done.
all right, I'm
Not
on
yet.
13.
Ah. Oh, that was sucky.
What?
Oh, I had I lost that one. It's because I had it open in another quiz. And so it says now there's a problem with your attempt. You might have already did this one. So now I have to write all the numbers back in again.
Oh.
I was like, oh, I was hoping it worked. All right. Now I got to do it for reals. Stratified. Cluster. Simple. Stratified. 4.711. 1.912. True. All right, number 11 is 0.0165, right?
Negative.
Negative 0.0165.
Yep.
All right, and then 12.6 or 0.681. None of those above. 0.715. False for 15, correct?
Yeah.
Extradural. Third quartile is 8. $50. 2055. 233. The bottom one. 0.5. Oh, 6847. 0.316. 388. 697. 27 is 461. 28, 624. 29, 542. 3. 31.123 and 0.032. All right, you got them all?
Almost at 2 more. Sorry, just like. Alright. I'm good.
Yay. Oh, we still missed it with I still missed 11, but that's all right.
Number 11?
Yeah. I probably wrote it wrong. What number did I write it? 0.0165. It's supposed to be 0.165.
Oh, man. Hey, at least we got, what was it, 15 or something?
Yeah, 15 we got right. Oh, the 14, yeah.
Yeah.
We got that one right.
We got that one out.
Yeah, I should have.
Those instructions should have been more clear on that one. That one was hard.
Yeah. Of what temperatures, yeah.
Well, we're going to get an A on this test, I know it.
Yeah, no, we are, dude. Awesome. I'm glad you helped me, man. That was cool. So,
Cool beans.
yeah. So I think we'll do all right.
Yeah.
I mean, I just got to remember the formulas and then the rest should be easy. We did pretty well on the rest of it, just getting the numbers.
Maybe.
So,
I don't think it'll be too bad. We're a good group, though. I'll tell you that.
what's that?
I said, I'll tell you that we're a good group, though.
Yeah. No, dude, it's awesome. Yeah, we kind of complement each other because, I mean, so I hope that Josh guy gets it, though. I mean,
Yeah, he sounds like he does.
Yeah, that's why I was like, I was hoping he was in.
Yeah, he emailed me, but he never showed up. So,
Yeah.
I told him that I got back on it. So,
Oh, did you?
Let me see what he said on his next email. If he sent one. Yeah, he said. He said because I sent it at 5:30, right?
Yeah.
And that's when he emailed it like 5:28, so just before. So I emailed him and said, "Hey, I just sent it out." But,
Yeah.
no, that's all right.
I know it's hard to do that stuff in those learning centers too. So,
Yeah.
and then you have limited time also. So,
Mm-hmm.